The goal for today's investigation is for you to be able to describe the solutions to an inequality by solving related equations and then reasoning about values to make the inequality true. So to begin with, I've got this word problem here, and we probably won't do all parts of it, but I think it's a good example of how to sort of solve inequalities in context. So we've got Andre, who has a summer job selling magazine subscriptions. He earns $25 per week plus, oh, that plus makes me think I should write in a plus symbol above it. Per, I'm going to think this may be important, so I'm going to underline that for a second. So he earns $25 per week plus $3 for every subscription. Ooh, for every is going to give me an indication that's probably like a unit rate that he sells. Andre hopes to make at least, this word at least is going to give me a clue that that's going to be greater than or equal to. If this had said at most, I would have written it the other way. That would have been a less than symbol. So he hopes to make at least enough money this week to buy a new pair of soccer cleats. Okay, so we've got some things sort of highlighted in here. That's sort of my general strategy when I'm attacking a word problem, is underlining or identifying key words that might help me write the math sentence out of that. So it wants me to use N to represent the number of magazine subscription Andre sells this week. Write an expression for the amount of money he makes this week. So I know that he's going to start with $25, and then he's going to add in $3 for every subscription. And so that would be how much he makes this week. And then if I think about this one, the least expensive pair of cleats that Andre wants to purchase costs $68. And so now I know that he needs to make at minimum $68, and so I could write that as this way. So I had to think for a minute, which way should I write my inequality symbol? But again, the context I'm pulling out of there is that if this is the amount of money he's making in a week and the cleats are this amount here, $68, then I know that what he needs to earn this week needs to be more than that. So I wrote my inequality as like this value has to be more than 68. Okay. So our general steps we're going to use in order to sort of answer some of these questions and to solve inequalities. The first thing I'm going to have you do is write an inequality. Let me move this over a little bit. There we go. Great. So the first thing we did was we wrote the inequality based on the context. And so we were able to pull that out of this word problem. The next thing we're going to do, and I'm going to kind of do these maybe on here. I sort of just rewrote this problem right here. It's that same problem, but now I've got a little more space to do this. So we wrote the inequality. The next thing to do is we want to simply rewrite this inequality as an equation by replacing the inequality symbol that we find with an equal symbol. And so I can simply rewrite what I had up here. All I've done is replace this greater than or equal to sign with this equal symbol. What that allows us to do is then solve for a variable, and we're going to use the same process we've been using throughout this year, where we use inverse operations to isolate a variable. So if I want to get this n by itself, the first thing I want to look for are any constants, so I'm going to subtract 25 from both sides, properties of equality. The additive inverse, that's why that disappears, and so now I get 3n equals, what is that, 43? And so now if I know that the math that's happening between this n and this 3 is multiplication, the inverse of that is division. So I need to divide both sides by 3. N equals 14 1/3. I could have written this as 43 1/3 or 43.3 repetent. That either one would have been fine. But why this is helpful now is what we can do. We know that the solution, if it was an equal symbol here, the solution would be 14 1/3. But what this provides us is this boundary. And so why this is helpful is now we can figure out which way do I need to write my inequality symbol. I can choose one value where n is greater than 14 1/3 and one value where n is less than 14 1/3. And I'm going to check. And I'm going to simply substitute those values that are on either side of this boundary to figure out which way does my symbol need to go. So let's make this, the choices you make for your boundary, your values greater than your boundary or less than, should make your life mathematically really easy. So maybe I'll choose like 15 for my number that's greater than. This one, so I could write this as 25 plus 3 times 15 is 68. And again, it doesn't matter what number I chose here as long as it's greater than 15, and I'm just trying to make my mental math life easier. So let's see here, 3 times 15, that's going to be 45. 25 plus 45, that would be, what is that, 70? Yeah, so 70 is greater than 68. So we want our symbol, that would be the correct one we would circle there. I can double check to make sure by evaluating for a number that is less than 14 1/3. So maybe I'll choose a number like 0 would make my life pretty easy. So 25 plus 3 times 0, is that going to be greater than or equal to 68? Well, 3 times 0 is 0. 25 plus 0, that's 25. 25 is not greater than 68. That does not work. So no dice there. Okay. So the reason I like doing it in sort of in this method is it helps me conceptually understand the context of why my inequality faces this direction. And so now what I'm saying is that any value that is greater than 14 1/3 will satisfy this equation. So we know back to our original problem here. It asks if Andre is selling 16 magazines, would he reach his goal? Yes, because that is greater than 14 1/3. So any other number that is greater than 14 1/3 would satisfy. He would still reach his goal. And so when we say write an inequality expression that Andre wants to make at least 68, well, that would be this initial thing up here. And the number of subscriptions using an inequality, well, that's like the solution. We say any number that's greater than 14 1/3. So I like sort of attacking problems involving inequalities in this format because, again, it conceptually helps you understand why your inequality symbol faces the way it does. When that becomes really important is when we are faced with slightly different problems, such as this one. You can still see all that. We've got this problem here, and let's go ahead and use this sort of strategy to help us solve this problem to see what happens to our inequality symbol at the end. So the first thing is we've written an inequality based on the context. So I've already done that for you. Let's say, it doesn't really matter in this particular case what it was, but maybe I had 9 versions of something that was originally $7, and then I subtracted a little bit because I wanted to make a price discount, and I wanted to all of that be less than 36. It would be maybe an example I could have pulled out. So first step, write an inequality. Check, I've done that. The next thing I want to do is rewrite as an equation, and so I'm simply going to replace any inequality symbol I see with an equal symbol. Now I need to solve for a variable. So this one here looks a lot like those divide and distribute options I was given earlier. I think I'm personally going to divide by 9 first because I know 9 is equally, or 36 is divisible by 9, and that'll just get rid of that automatically. So I have 7 minus x equals 4. This minus x I don't love because if I just move this 7, then I'm going to have this negative x I'm going to have to deal with. So I think I might move this x over here by adding a positive x to both sides. So then I get left with 7 equals x plus 4. The reason I did that was that if I dealt with the 7 first, I would have had this negative in front of this x, and I would have had to divide everything by negative, and I just generally don't like doing that because I tend to make mistakes. So if I can add or subtract versus multiply or divide, I typically do that. So now my last thing is I need to move this 4, and the way I'm going to use that is by the additive inverse. And so I can subtract 4 there, and so then I'm simply left with x equals 3. So now I have 2 choices. So I've solved for my variable. My solution is the boundary. I need to check to figure out which direction my inequality is going to go. So I'm going to choose numbers on either side of the boundary. So I need one value that's x is greater than 3 and one value that x is less than 3. And so now we're going to plug this number in, whatever number is greater than 3, in for here and evaluate. So I might rewrite this as 9 times 7. Let's do 5. 5 is a pretty easy number mathematically. That'll make this expression easier to solve. So 7 minus 5 is 2. And so PEMDAS says I need to do what's inside this parentheses first. So 7 minus 5 is 2. And 9 times 2 is 18. So 18 is oops, sorry, this should be equal. I wanted this to go this way, sorry. Good Lord. This is why I like to do checks, because I chose a number that was, oh, good Lord. No, I had it the right way the first time. Goodness gracious. Okay. My original equation I want to know is 18 less than 36. Yes, it is. Holy bananas, that was hard for me. So the reason what just happened in my brain, what just happened was I freaked out for a second because I was like, wait, the inequality symbol flipped. That is okay, because what we're now figuring out is, ooh, if your x value is greater than 3, when I actually evaluate that equation, it will be less than this value over here. So you just watched my brain have a little freak out because I watched the inequality flip and I wasn't ready for it. So that is a normal thing that can happen, that I started with an expression over here where my inequality looked like maybe I thought it was going to be x is going to be less than something, but ultimately when I solved it, conceptually, it needed to be greater than. So let's check to make sure I didn't make a mistake. So I'm going to plug in now a value that's less than 3. So maybe we'll do 0. So 9 times 7 minus 0, and I want that to be less than 36. There we go. 7 minus 0 is going to be 7. And so 9 times 7, that's going to be 63. 63 is not less than 36. That does not work. So this one doesn't work. So again, big takeaways from this lesson. When we solve inequalities in context, you're going to attack the problem to figure out how to write your inequality. Then simply rewrite it as an equation, replacing the inequality symbol with an equation or an equal sign. Solve for the variable using your inverse operations skill set, and the solution is our boundary. And then to figure out which direction should ultimately your inequality symbol face for your solution, we are going to choose values on either side and substitute in. And then our final thing would be to write our solution as an inequality, ensuring the symbol faces correctly based on context. So this is again where I'd want to go back to my problem and be like, does this actually make sense with whatever my problem was?